This video is about tree diagrams. As we know, for sample space, we have so many ways to represent or illustrate sample spaces. One of them is a tree diagram. So in this video, we will talk about tree diagram. This will be the typical tree diagram. Normally, you get started from one point. And remember, from one point, you have branches. Suppose this is A, this is B. You will put the probability and write down like that. And you have A plus B equals to 1. For compound event, for example, CD, and this one will be the compound event from this. Here's 1, 2, 3. These 3 events form a compound event. The probability will be A times C times D. You just multiply A times C times D. If I have this E, then C plus E equals to 1. All the events, you will get the probability. We call this is a P1, P2. Then it's a P3, P4. Keep going. Then all these events adding together, that will be equals to 1. Let's go to guided practice 1. Consider 2 archers firing simultaneously at a target. Lee has a probability 3/4 of hitting a target, and Yuka has a probability 4/5 of hitting a target. How to draw the tree diagram? You will check how many probability for this Lee. Lee fired, and then there will be the 2 possible results. One is hit the target or missing the target. That's the reason for Lee. The first one is for Lee. Then they have 2 branches, 2 possible results. I will put H for hit, then this for missing. Hit will be 3/4. Missing 1 minus 3/4 will be 1/4. Then it's for Yuka's turn. When Lee hit the target, Yuka fired. There are 2 results also. So from Yuka, I have a hit and missing. Same thing. After Lee missed the target, then for Yuka has 2 possible results. One is hit the target or missing the target. The probability for Yuka hitting a target, that is 4/5. Missing will be 1/5. 4/5 or 1/5. We call this is a tree diagram for this compound event. But you have Lee hit and Yuka hit the target. We do the probability that's 3/4 times 4/4. That equals 3/5. That means both hit the target. For this line, that means you go to this one and this one. You will have 3/4 times 1/5 equals 3/20. Which means Lee hit the target while Yuka missed the target. Then go to this one. And go here. You will have 1/4 times 4/5 equals 1/5. That's Lee missed while Yuka hit the target. Then we go to this line. This line and then this line. Both miss the target. So we have 1/4 times 1/5 equals 1/20. That means both miss the target. If you add all this, like 3/5 plus 3/20 plus 1/20 plus 1/5, which means all this, your answer will be equals to 1. Let's go to B. Find the probability that at least one of them hit the target. Therefore, you have to check this. This at least one of them hit the target. I need a H. This is a 2H. This good. 1H here, 1H here. This one is not. Therefore, for B solution, at least one of them hit the target will be 3/5 plus 3/20 plus 1/5. You need to add these 3 together. This will be your answer, equals 19/20. Look at the C. Find the probability that only one of them miss that target. I need a 1 missing. So this one working, this one working. That means you need to add these 2 number. So we have 3/20 plus 1/5 equals 20. Here's 7/20. Therefore, for tree diagram, you have to know how to analyze the tree diagram. Let's go to guided practice 2. 2 drawers contain some colored ball as indicated in the diagram below. 2 experiments are carried out. First experiment. A drawer is first chosen at random and then a ball is drawn from that drawer. So this is a compound probability. You have first randomly choose the drawer. You have 2 possibilities. That's why we do here. The first one is you choose the drawer. Then second one is you will draw a ball. For the draw, how many possible results you will have is 2 because you have draw 1 and a draw 2. So I write down here it's draw 1 and a draw 2. Probability will be 1/2. If you got the draw 1, then for the ball, you have a black and a white. The probability for draw 1, black will be 2/5. White will be 3/5. If you got the draw 2, then we go to the draw 2 now. Altogether, it's 3 balls, white and black. So we still have black, white. Black will be 2/3 and white will be 1/3. That is for the first experiment. Now we can analyze this tree diagram. So for this line, you will get a draw 1 and a black ball. It will be 1/2 times 2/5. You don't have to work this out. Then we go to this line and this line. That's the compound event will be draw 1 and a white ball. It will be 1/2 times 3/5. For this line and this line, you have draw 2 and a black ball. We have 1/2 times 2/3, this 2. Then we have draw 2 white ball. That is 1/2. This is multiplication times 1/3. After you label this tree diagram fully, then we need to answer these questions. What's the probability that a white ball is drawn? You have to check where's the white ball. You could see here's draw 1 white and draw 2 white. So this one we add together. You will get 1/2 times 3/5 plus 1/2 times 1/3. Put into calculator, you will get 7/15. Let's go to second experiment. The ball drawn in the first experiment is not replaced. A second ball is then drawn from the same drawer. What's the probability that both balls are the same color? Now we keep drawing this tree diagram. Then we need to draw the second ball. For the second ball, it's not replacement. Therefore, second ball could be black and white for all of these. For the first ball, black, that's for draw 1. And then you draw another black ball. Altogether will be 4 left because this is a not replacement. And since you took 1 black, so have 1 black left. And still 3 white left. Since you took this time, it's a white. Therefore, you have 2 white left. You still have 2 black left. You have to check each branch. Like these 2, adding will be 1. 1/4 plus 0/4 equals 1. 2/4 plus 2/4 equals 1. Then for draw 2, since you took 1 black, therefore you have 1 black left, it will be 2. And here's all 2. You took 1 black from the draw 2, and you still have 1 white left, 1 black left. If you draw 1 white, then you have 2 black left, 0 white left. Now, you can get from here is draw 1 black, black. Draw 1 black, white. Draw 1 white, black. Draw 1 white, white. From draw 2, you get the draw 2 black, black. Draw 2 black, white. Draw 2 white, black. Draw 2 white, white. Then for the probability, that will be 1/2 times 2/5 times 1/4. For this line, it will be draw 1 is 1/2. Then it's 2 over 5, 3 over 4, 1 over 2 times 3 over 5, 2 over 4, 1/2, 3 over 5, 2 over 4. For draw 2 black, that is 1/2 times 2 over 3, 1/2, 1/2, 2 over 3, and 1/2. For this one, 1/2, 1 over 3, and 2 over 2. Since 0 over 2 is 0, that's why this one will be 0. For this C, what's the probability both balls are the same color? Which means I'm looking for black, white, black, white. So I add all these 3 probability you will get for C. That will be 1 over 2 times 2 over 5 times 1 over 4 plus 1 over 2 times 3 over 5 times 2 over 4. Then plus 1 over 2 times 2 over 3 times 1/2. Then plus 0. Then we put into a graphing calculator, you will get 11 over 30. Let's go to D. What's the probability that both balls are different colors? There are 2 ways to do that. One way is you check this. Then add these 4 together. Or you can use 1 minus 11 over 30. Then it will be 19 over 30 will be your answer. Now let's go to guided practice 3. Copy and complete this tree diagram about people in the armed forces. All these 3 branches adding together will be 1. Therefore, for this one, you will get 1 minus 0.22 minus 0.47. So you get 0.31. For this, you will do 1 minus 0.19. You will get 0.81. 1 minus 0.85, 0.15. 1 minus 0.21, that's 0.79. What's the probability that a member of armed forces is an officer? From this one, you will get the Navy officer. Navy not officer. Let me write down N, not officer. This one is the Army officer. Army not officer. Air Force officer. Air Force not officer. So when you're looking for is an officer, that's you have 3 outcomes. That means for this line and this line. Then go from here to here. We multiply by the probability, like these 2 multiply, then these 2 multiply, then you adding. So you get the first one, you will get 0.22 times 0.19 plus 0.47 times 0.15. Then plus 0.31 times 0.21. So we put into a graphing calculator, you will get 0.1774. This is the accurate answer, so you don't have to change it into 3 significant digits. This is an accurate answer, preferred. Let's go to second question. It's not an officer in the Navy. Let's check Navy. It's not officer. That means this one. So you have 0.22 times 0.81 equals 0.1782. Let's go to number 3. Not an Army or Air Force officer. We will check Army officer. That's Army officer is this. This is not. Air Force officer is this one. So you can do is 1 minus these 2. So you have Army officer, that is 0.47 times 0.15. Then keep subtracting Air Force officer, that is 0.31 times 0.21 equals 0.8644 will be the answer. Let's go to guided practice 4. Machine A makes 40% of bottles produced at a factory. Machine B makes the rest. Machine A spoils 5% of its product, while Machine B spoils only 2%. Using a proper tree diagram, determine the probability that the next bottle expended at this factory is spoiled. First of all, you will check machine. You have machine A and machine B. Machine A, that's 40%. Machine B will be 60%. Then for the machine A, we go to spoiled. See, I use S stand for spoiled. Then this one is not spoiled. I use N stand for that. So 5% is spoiled, the product, but 95% is not. From machine B, same thing, spoiled and not spoiled. Spoiled, the product will be 2%. This will be 98%. Therefore, for this line, you will get the machine A spoiled, machine A not spoiled. This one is machine B spoiled. This one is machine B not spoiled. So you have 40% times 5%. This one will be 40% times 95%. This will be 60% times 2%. 60% times 98%. Because you got to go this line and this line. So you get these two. We are looking for the next bottle expended at this factory is spoiled. So we're looking for machine A spoiled or machine B spoiled. We add these two together. The probability equals 40% times 5% plus 60% times 2%. Then we put into calculator, you will get 3.2%.